Hi, everyone. My name is Jennifer Herron, and I am the founder and CEO of Action Engineering. I was invited to talk to you today about getting started with MBD, or model-based definition. Starting with why you even need to think about MBD. Because of COVID, now is never a better time to make your manufacturing organization competitive, resilient, and sustainable. How do you get that done? Yes, with new software tools, but those tools don't develop and deploy themselves. So you will need a cross-department, highly functioning MBD implementation team, and their key focus should be communication across the enterprise, authoring thorough and vetted playbooks, and fostering an education strategy that renovates your culture to using 3D data over 2D drawings. What is the result? Connected, traceable, and trusted 3D data. Let's go deeper on why MBD is worth doing. Here is my list of what capabilities improve using MBD. Requirements capture, revisioning, 3D navigation, document traceability, commenting, quality pedigree, document integration, parts lists, manufacturing instructions and planning, and CAD reuse. You will see these manifest through the rest of the talks today. Make some notes for yourself and keep an eye out for other messages that resonate with you and your organization around the benefits or the why of MBD. Whether you are new to MBD or a veteran, you know that every perspective or viewpoint in an enterprise thinks of it slightly differently. The CEO thinks, this is an instant transition. Put in a new technology, write a memo. Why aren't we done yet? Marketing thinks, 3D, this is virtual reality, right? At the beginning, engineering thinks it's a utopia without any pesky people on it, but then they realize people are challenging and the beach is crowded. Manufacturing thinks it's a big mess of change they will have to untangle. Quality thinks it's a whole bunch of new tools and methods they have to account for, and they just aren't sure how to use it. Supply chain is often juggling fire anyway, handling different information from different customers. This is just a different torch. Customers are like CEOs, oblivious to the complexity of the change and just not sure why it's not done already. And it's actually a long, winding journey with a lot of switchbacks and moments where you feel like you haven't made a lot of progress up the hill. Let's go even deeper. Per ASME Y1447, model-based definition is an annotated model and its associated data elements that define the product in a manner that can be used effectively without a drawing graphic sheet. Model-based definition is the result of a methodology within engineering that keeps the digital model central to all design activities. Model-based engineering is a process that governs how the digital model is developed, manufactured, and flows through the life cycle. This is often referred to as the digital thread. A model-based enterprise is an organization that uses a model-based engineering process approach and uses model-based definitions for the purpose of commission, operation, service, and decommission of a product. And finally, a model-based environment is an ecosystem defined by software, hardware, infrastructure, and people that supports both a model-based engineering approach and a model-based enterprise. When it comes to the level of effort for implementation and the synergistic effect that going model-based has on an organization, MBD is just the tip of the iceberg. You've likely heard the term digital thread or digital twin. These are big concepts that describe our collected vision to connect together digital data. The functional areas that use 3D data today are engineering, manufacturing, quality, suppliers, and analysis. There are many 3D data sets you can use across the life cycle of any part. They vary from industry and tool suite. The goal of the digital thread is to digitally connect trusted data with other organizational information to create a consistent data-rich thread that provides value to your company and maximizes your software tool investment. If we connect other organizational data alongside MBD data, then we create the beginning of a model-based enterprise. Data that is reused is data that has value because it informs good decision making, which in an organization always is needed to maximize the bottom line. So data collected and not reused has limited value to the organization because it must be recreated or does not provide a return on the effort of collecting it. An example of data that has limited value today is the common practice of relying on 2D static drawing information alone. 2D drawings are often printed on paper, digitally disconnected, and out of date. 2D drawings create inefficient schedules as traceability relies on manual data entry and revision distribution is physical. By digitally connecting to the source design model, there is an opportunity to introduce new workflows that reduce ambiguity, reduce data input errors, increase traceability, and improve efficiency. With MBD, our data that is reused, meaning MBD 3D data, has more value than a 2D drawing. Organizations undergoing a digital transformation are also considering upgrades to their fabrication operations. Today, many of those connections are manual and rely on people physically carrying drawings around on the shop floor. Data reuse for MBD means we maximize machine consumption, increase organizational collaboration, and engage typically siloed business areas with a holistic approach to interconnected data. Let's go even deeper and compare a drawing with model-based definition. A drawing is a static, two-dimensional presentation of geometry and annotations. Often these drawings are fraught with ambiguity. My biggest pet peeve of drawings is that they are often faxed to suppliers, and the low resolution of the facsimile muddles the certainty of the leader lines associated to the geometry for dimensions, leaving the supplier confused and uncertain. Drawings require a human to read them and input the information into another system. In fact, we have analyzed that there are 6 to 20 manual handoffs during any one OEM to supplier interaction for a single product. So that's a lot of manual handoffs, leaving a lot of room for error. Anything we can do to eliminate manual handoffs helps reduce the cost of poor quality. Look at the MBD. It's rotatable, zoomable, and queryable. It is a combination of geometry, annotations, attributes, and presentation states that are digitally captured. Because the model is digital, this means everything is captured in ones and zeros, and humans are not required to interpret what that data means. Nor do they have to re-enter the data from one system to another. Metadata and engineering requirements can flow from the MBD into manufacturing, quality, and ERP systems. And my favorite thing about MBD is I never second guess myself about where a leader line is pointing because it highlights the represented geometry. The accuracy and dynamic viewability of MBD information makes me trust 3D data much more than I ever trusted 2D drawings. To further convince you that 3D data is more valuable than 2D drawings, let's look at the common practice that goes on today to create a drawing. A designer or product definition practitioner creates a 3D model today, then they use the CAD software to unfold that model to create a flat, static 2D drawing. Shouldn't we just leave the data in 3D instead of performing that extra effort? It's not like we don't all carry computers capable of viewing 3D in our pockets. Oh, wait, yes we do. Okay, we went deep into MBD, but let's talk now about how we control and protect all that digital data. The digital thread and MBE are based on having a single source of truth for your products. That does not mean there is one 3D model to rule them all, but rather an established system of master authoritative data sources that flow through derivative data to machines and humans who consume that information. However, interconnected, searchable, and democratized data does not mean that all data is available to everyone all the time. Access control is a key feature of the connected enterprise and determines who may see data, who may change data, and who approves the data. Data stakeholders have access to released and authorized data appropriate for their needs. The philosophy of model-based definition is not just to use MBD in engineering alone, but to reuse 3D CAD data throughout enterprise functions and into the supply chain. Data-rich threads of connected, trusted data provide value. We are seeing time savings up to 75% in certain processes of the business due to using MBD. That's really big numbers. I will note, however, to achieve those really big numbers, you do have to make an investment. The investment costs have to include enterprise-wide training and upskilling so that your people can actually use the MBD data. If you skip that step, your MBD implementation efforts will be for naught, because the pushback from the 3D stakeholders who were not involved from the beginning, i.e. everybody but engineering, will absolutely kill your MBD progress. Of all the MBD implementations I've seen, the technology varies, but the need to teach people how to utilize the new way of doing business is always present. Understanding the people in your organization really do make or break technical projects. Organizations that succeed in this complex transition take the time and effort to integrate cultural as well as technological changes. This certainty applies to all organizations. And my key advice for MBD implementers is plan your pilots carefully, train according to the needs of the people, and communicate and create paths for feedback. In the following sessions today, you will hear stories about real companies implementing MBD. Listen carefully to their successes, but even more carefully to their challenges. Their perspectives will inform your strategic implementation plans. There's no right or wrong way to achieve MBD. There is only the way that brings you the results your business needs. So what is MBD? It is connected, traceable, trusted 3D data. How do you achieve it? Communication, 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 communication. Humans have to hear, see, touch, and interact with MBD before they feel the benefits and understand What is in it for them? And finally, why should you do it? Every company is rethinking their strategies due to last year's pandemic. MBD is a foundational capability that achieves operational resiliency. Empower your enterprise with connected, traceable, trusted 3D data. Then you can realize the next generation of savings. And who doesn't want faster cycle times with increased quality? Finally, look, I get it. Change is hard. Be brave, innovative, yet thorough. I appoint each of you to learn to be change agents and advocate for MBD. Or you could avoid changing anything, and I guarantee in 3, 5, or even 10 years, you will still be doing the same old things, expecting a different result. And that, my friends, is the definition of insanity.
Hello everyone, my name is Michael Fridman and I am a product manager for model-based definition in Creo. I have Evan Kessig with me. Evan is the owner of GE Appliances machine-readable MBD strategy, and today Evan will present about the journey that GE took for implementing MBD in their organization and about its reuse in their digital enterprise.
Thank you, Michael, for that great introduction. And I'd like to thank PTC for allowing GE Appliances to share their story. Let's start off by talking about how to become a digital company. Internally, when we discuss and train our organization and discuss a digital enterprise, we need to change the way that we think, act, and grow. We need to think digitally, right? Implementing a successful digital enterprise strategy requires a mindset shift to think digitally. Leveraging a model-based definition throughout the business to streamline workflows back to a single source of truth. Thinking digitally means understanding what inputs your digital enterprise software needs to automate standard workflows, assuring that the authoritative sources are accurate and machine readable. Act digitally, identifying key areas of the business to act digitally. Leverage product and manufacturing information to create a traceable digital thread. So acting digitally means identifying areas of the business that can be connected to the digital thread to have the greatest impact. And grow digitally. Build up expertise to grow digitally and provide business and industry guidance to keep forward momentum in model-based enterprise. Knowledge capture and knowledge sharing is important to our digital enterprise to grow and to transform the way that we work. So growing digitally means building up expertise in model-based enterprise to educate the business and to keep up with industry trends. Reusing model-based definition with the digital enterprise is a powerful tool to automate workflows. So we know that becoming a digital company means that we have to identify key areas of the business that can leverage model-based definition. And so the foundation to any successful digital enterprise is your model-based definition strategy. So it's important for us to understand and identify the difference between human-readable MBD and machine-readable MBD. And so let's take a look at GE Appliances' MBD strategy. We started our MBD journey back in 2015. Prior to 2015, like many of you, we were creating three-dimensional models that would drive two-dimensional views on a 2D drawing. And we would package this data up into a technical data package or create a 2D PDF to communicate downstream product definition. And we realized that this data set was only human readable. This data set would only complement a human readable strategy. And that if we wanted to move to more of a machine readable strategy within our digital enterprise, we needed to move to model-based definition. So in 2015, we got a directive from our leadership, which is key, that our leadership knew the value and the benefit of model-based definition and its success to a successful digital enterprise. So in 2015, our model-based definition team set off to deliver our first execution of model-based definition. And that execution is here. We still call this human readable MBD, but all of the product definition is embedded within the model. We realized that when we started working with companies like CapVidia to implement a QIF workflow, we realized that we could do much more with our MBD if we started adding the semantic references that complemented the function of each annotation. So that way, on top of being human readable, we could also be machine readable, and we could communicate better, have better interoperability with all the software within our digital enterprise. So in 2018, we delivered a new iteration of our model-based definition strategy that is human and machine readable. And this is key. This is key to unlocking the doors to your digital enterprise and making sure that it is successful. You need to complement a human and a machine readable strategy. And so now every annotation, whether it's GD&T, coordinate linears, whatever phase you are in this process, make sure that all the semantic references are there to complement. And whatever input you're trying to feed to a downstream software, that should come from your authoritative model. Let's talk about the digital enterprise. I've referenced the term digital enterprise multiple times now, and so let's define it. And at GE Appliances, we've defined the digital enterprise as an organization that uses digital models to conduct business activities generating a traceable digital thread. So when we think about digital models, that's this down here. We can think about our digital product or our authoritative CAD model. And we know that we're doing things in model-based definition, and that's the key here to the digital enterprise. And all of our product definition is machine readable inside of this authoritative CAD model to be leveraged throughout the digital enterprise. So from concept to production, right, we have various different business activities that we can perform where we can leverage this authoritative CAD model, right? And we're going to create a traceable digital thread. And within that, we have the enterprise, we have lots of data that can flow and is flowing. And in some cases, we have data that's flowing in two directions. And in this case, we have, for instance, we could use 3D tolerance stack-up analysis software that can read this authoritative CAD model, this PMI, to automate the modeling of this analysis. The same thing with real-time simulation that's embedded right into Creo using ANSYS. Right? We can use those types of tools to perform these business activities that are connected to the digital thread. Same thing within build and manufacture for our virtual manufacturing, virtual builds, right? We can use QIF workflows for our qualification efforts and metrology, right? So we have data that's flowing all over the digital enterprise. And within these business activities, we want to make sure that we're creating a traceable digital thread back to the authoritative CAD model. And we want to be sure that these softwares that we're using to conduct these business activities, the inputs that they require, when they can, they're coming from the authoritative CAD model. We do know that other pieces of information need to come from other sources, but where we can, we want to make sure they're coming from the authoritative CAD model. And then we can use softwares like Navigate, right? We call this digital connectivity. So Navigate is an IoT platform software where we can use this to kind of glue together all of this data, right? This digital thread and have it available at the fingertips of our engineers. Let's look at the digital enterprise, a model-based enterprise, in a different way. Thanks to Action Engineering for sharing this slide. And I encourage you to reach out to Action Engineering as they're very versed in this space and they can help coach and mentor you along the way. Right, so looking at all the various different areas of the business, right? So we talked about from concept to production, right? The business activities, but there's lots of areas of the business that are affected, like design, manufacturing, quality, suppliers, and any analysis that you want to perform throughout the parts or product's lifecycle. It's important for you to identify areas of your business that you want to grow digitally, right? So as we talk about becoming a digital enterprise, we need to identify the areas of the business that can leverage and maximize the 3D tools you already have in place, that can read this product definition and to streamline various different processes, right? And maximize people's digital skills. As an example, moving to model-based definition has improved our communication with our suppliers. It took some coaching and mentoring at first because we changed from a two-dimensional data set to a three-dimensional data set. But we showed them we can extend the benefits of model-based definition and our digital enterprise to them, right? On top of that, we are now, instead of giving them a two-dimensional derivative, right, a dead-end derivative, we're now able to give them a Creo view or a 3D PDF that communicates semantic references and removes any ambiguity that they may have, right, in interpreting our product definition. So identify the areas of the business to leverage this same technique and same ideas, right? To showcase the value and to provide and gain leadership buy-in. Let's take a few minutes and talk about MBD. So I know many of you are beginning your model-based definition journey, right? And we're throwing a lot at you with creating model-based definition, making sure that it's machine readable, and finding softwares that can read and do something with this data, right? And it's something that you have to take in steps and in strides, okay? But when we educate our business, it's important for us to break down model-based definition. The pieces of information that our digital enterprise needs, I kind of classified it into three different categories. Geometry, right? I think as soon as the first 3D model was created, we've been leveraging geometry throughout our enterprise, and we're very good at it. Where we need to become better and where model-based definition helps is PMI. So that's product and manufacturing information. PMI is just simply all of the dimensions and tolerances and notes, whether it be local notes, that define product definition, okay? And then also notes and title block, right? So this is also embedded inside of the model, the MBD model, but it communicates material, appearance, texture, standards, and any testing that's needed. This can be implicit or explicit information. Whatever your strategy is, right? That's something that you have to define as an organization, but make sure that the mind frame that you have is that it complements the digital enterprise and the areas of your business that you want to affect. Let's talk about the business impact, right? That model-based definition versus the two-dimensional drawing. I think you get the idea that model-based definition is more superior than a two-dimensional drawing. But I want to show this visually, right? And I also want to state that creating a three-dimensional model and a two-dimensional drawing takes more time. It's more data that we have to manage and the linkages within your PLM system than creating a machine-readable model-based definition. On top of the benefits that we've already discussed throughout this discussion, look at the impact shadow that a machine-readable MBD database has on the organization and our business versus a two-dimensional drawing driven by a 3D model, right? The business impact areas, you guys can define that within your organization, right? But the benefits, you can't deny this, right? We're communicating design requirements through a single source of truth. We have increased efficiency. We're doing more with less resources because we're streamlining workflows. Less derivative data set creation, right? We're reusing our CAD data. That's unheard of, right? We weren't reusing our CAD data hardly at all when we're driving a two-dimensional drawing. We have increased interoperability downstream, right, between our softwares, and it will only continue to grow as more softwares are integrated into the digital enterprise. We have better data faster, right? Making better decisions. And we're faster to market because of it. If it takes me less time to create machine readable MBD, than it does to create a 3D model driving a two-dimensional drawing, and I gain all of these benefits, it's something that's definitely worth looking into. And that brings us to the end of our discussion. I want to thank you for allowing GE Appliances to share our story. And I leave you with these key takeaways. I'd read these to you, but I'm past my time, and you can read them just as good as I can. Thank you very much.
Well, thank you, Evan. This was very insightful, and it's clear that organizations like GE Appliances can benefit a lot from such digital transformation to MBD. Let me ask you a couple of questions about the journey and the process that your company took. What would you say were the major roadblocks and challenges you have encountered during the process of adopting MBD in your organization?
So when adopting model-based definition within your organization, there's two roadblocks that come to mind. So we need to upskill our personnel. So that way we need to train them and educate them in how to author machine readable PMI. And also we have to train our organization, who are the interpreters, on how to read the machine readable PMI. And we also need to educate them on the benefits of machine readable PMI. Why are we moving from a 2D data set to model-based definition? And when we educate them on the benefits, right, they're more on board and accepting to this new process and this new change. So we need to articulate the value of model-based definition within the enterprise.
Perfect. Another question I have, it seems that the industry does not yet have a consensus for either working with minimally versus fully annotated models. What is your take on this?
Oh, yeah, let's talk about minimally versus fully annotated models. So when we think about fully annotating a model, we're defining product definition for critical and non-critical features. And so this could be a very large amount of PMI that's being authored within your model-based definition. And some fundamental rules from ASME Y14.5, fundamental rule B and C, state that dimensions and tolerances shall be complete, right? So there's full understanding of product definition. And when we look at these fundamental rules, they state that everything must be fully defined. But there are some approaches to minimally dimensioning or minimally annotating our MBD models. And there's some benefits to that, where we don't have to spend a lot of time on measuring during PPAP or metrology, measuring these non-critical features. And that we can leverage, say, an all-over profile or a title block tolerance that can control these things. The supplier is still responsible for them, but we don't have to spend so much time and focusing on non-critical features. So I think there is a place for minimally annotated models, and I think it comes down to how you want to implement that within your organization.
Right, and I guess for those features that are not indicated, let's say, you could go and just interrogate the model directly if you need some information that is missing for you.
Yeah, exactly. And I think that there's one thing to consider is when you're using GD&T per, say ISO or ASME, there's one thing that you can do to limit the amount of PMI that you're authoring. And when you limit the amount of PMI that you're authoring, that also cuts down on how much PMI you need to make sure is machine readable. But say basic dimensions. So if you specify that basic values, they still exist, but they must be queried from the CAD model, and which also requires that your downstream audience knows how to go and query those items from the CAD model. But that will save you a tremendous amount of time when authoring model-based definition, just by simply not authoring basic dimensions. And in some cases, we found that basic dimensions are needed for clear communication downstream. And in those specific instances, we will provide those basic values through the model-based definition, just to provide clear communication.
Yep, makes sense. What would you say is the biggest win that you see with model-based digital enterprise?
I would say hands down is the interoperability downstream by leveraging our machine readable PMI. And so that's all the annotations that define product definition. All of that is machine readable, and we can handshake that data with all of the software within our digital enterprise. And you know, we talked a lot about in this presentation about the digital enterprise and the areas that you can focus on, but I think it comes down to each individual company and how they want to implement this to show that value. And I think that even if it's as simple, right, your approach at the beginning is as simple as leveraging this machine readable PMI just to remove ambiguity. You know, if you think about going from a two-dimensional world, 2D drawing PDF to say a Creo view derivative of your authoritative model. So for instance, let's take a look at this 4x hole pattern with our composite tolerance. So imagine this is a two-dimensional PDF or drawing. And as a human interpreter, right, I can see that I have a 4x hole pattern with a positional tolerance associated. And yes, you know, I have a nice grouping of 4, but let's say that that 4 hole pattern could be spread out on a very large part. And at that point, I have to assume as the interpreter which 4 holes I'm talking about. Or if I have a lot of holes and it's 4 of many, it's hard for me to understand. And one of the values of assigning semantic references and making our PMI machine readable is that when I select the annotation and say this is Creo view, you'll notice that I have all the semantic references that complement the function of this annotation highlight. And it's the same thing with the positional tolerance, that the functional features that are associated to this highlight. And I can do that for many different things as I make them machine readable, right? So datum target D1 is an area, right? A cylindrical area of 1.5, and here is that area, it's highlighted. And here is a profile tolerance that's associating how much surface deviation that area can have. And I have all of that being expressed here through machine readability. And so hands down, this is a way better tool for us to provide to our suppliers to showcase them the benefits. And so even if you use this as a simple tactic or a simple way to showcase the value, it removes lots of ambiguity from a two-dimensional drawing that a person may have when interpreting.
Yep, great. Thanks, Evan. I guess final question I would have, probably many people who are watching us are probably wondering what should be the list of actions they could follow in order to correctly jumpstart MBD projects in their own organizations. Can you try to define maybe a suggested path and actions for them?
Yeah, certainly. I think that for anyone that's wanting to dip their toe into the into model-based enterprise, into the enterprise pool, I think that start small, right? And I think that that's key. Start small and identify a champion within your organization to kind of be the architect. There's many different ways to kind of implement a model-based definition strategy within Creo. And you want to make sure that that model-based definition strategy complements current softwares that you already have in your ecosystem within your enterprise. I would start off with small pilots, right? So identify key areas of the business to showcase the value of model-based definition and pilot those, right, with something small and educate those team members on those projects to get them on board to help showcase the value here as well. Also, you know, get leadership buy-in early, and I think you can do that through these small pilots and also showing the value of how you can leverage model-based definition, whether it's with a simple strategy like just through Creo view or a 3D PDF, or into tolerance stack-up analysis or whatever the strategy may be. Showcase that value and how it can streamline workflows. And then also, I would encourage everyone to use the MBE maturity matrix to understand where you're at today and then where you want to go in the future, right? And I think you can use that as a good roadmap and a starting point.